we need to find out the value of the following. So let's begin. First, we are going to rewrite the expression. So we have sine theta minus cosine theta whole raised to the power of 4. We can also express this as cosine theta minus cosine theta whole squared whole raised to the power of 2. So this is going to help us when we expand it. We can easily expand sine theta minus cosine theta whole squared. Plus we have 6 times sine theta. We're going to expand sine theta plus cosine theta whole squared in the next step. Plus 4 times sine theta whole raised to the power of 6 plus 4 times cosine theta whole raised to the power of 6. Fine. So let's expand sine theta minus cosine theta whole squared. So we have 3 multiplied 2. So sine squared theta plus cosine squared theta minus 2 times sine theta times cosine theta whole squared. So we have used a minus b whole squared equals a squared plus b squared minus 2ab plus 6 times. So we'll expand sine theta plus cosine theta whole squared to give us sine squared theta plus cosine squared theta plus 2 times sine theta times cosine theta plus 4 times sine theta whole raised to the power of 4 whole raised to the power of 6 plus 4 times cosine theta whole raised to the power of 6. Now we know there's a standard identity which states that sine squared theta plus cosine squared theta, so that's always equals to 1. So this is known to us. So we can use this particular identity and replace sine squared theta plus cosine squared theta with 1. So let's do that, and this is going to give us 3 times 1 minus 2 times sine theta times cosine theta whole square plus 6 multiplied to 1 plus 2 times sine theta times cosine theta plus 4 times sine theta whole raised to the power of 6 plus 4 times cosine theta whole raised to the power of 6. Fine. Now we'll further simplify. So here we have 1 minus 2 sine theta cos theta whole square. So we'll also have to expand this. So let's expand it. So you're going to use the expression a minus b whole squared gives a squared plus b squared minus 2ab. So we have 1 plus 4 times sine squared theta times cosine squared theta minus 4 times sine theta times cosine theta plus we have 6 multiplied to 1 plus 2 sine theta cos theta. So that gives us 6 plus 12 sine theta times cosine theta, and the rest of the term we have 4 times sine theta whole raised to the power of 6 plus 4 times cosine theta whole raised to the power of 6. So let's distribute 3 with each of the terms. So we have 3 plus 3 times 4 is 12. So we have 12 sine squared theta times cosine squared theta minus 3 times 4 will be 12. So we have 12 sine theta times cosine theta plus 6 plus 12 sine theta times cosine theta plus 4 times sine theta whole raised to the power of 6 plus 4 times cosine theta whole raised to the power of 6. So negative 12 sine theta cosine theta and positive 12 sine theta cosine theta cancels out. 6 and 3 will get added to give us 9. So we have 9 plus 12 sine squared theta times cosine squared theta plus 4 times sine theta whole raised to the power of 6. Now here we can see that here what we can do, we can rewrite cosine theta raised to the power of 6 as 4 times cosine squared theta whole raised to the power of 3. The reason why we're doing this, we're going to convert all the cosine function to its sine equivalent, because we already know that sine squared theta plus cosine squared theta that's equals to 1, which means that cosine squared theta can be also expressed as 1 minus sine squared theta. So wherever we have cosine squared theta, we're going to replace with 1 minus sine squared theta. So let's do that. So we're going to get 9 plus 12 multiplied to sine squared theta. So in place of cosine squared theta, we're going to replace with 1 minus sine squared theta. Then the next term, that's fine. We're going to keep it in terms of sine. We have 4 times sine theta whole raised to the power of 6 plus 4 times. Now we're going to replace cosine squared theta with 1 minus sine squared theta whole cube. So this is going to give us 9 plus 12 sine squared theta minus 12 times sine theta whole raised to the power of 4 plus 4 times sine theta whole raised to the power of 6 plus 4. Now we need to expand 1 minus sine square theta whole cube. So let me state here that whenever we have a minus b whole cube, so this can be also expressed as a cube minus 3a squared b plus 3ab squared plus minus b cube. So we're going to consider a to be equivalent to 1 and b to be equivalent to sine squared theta. So this is going to give us a cube will be 1 minus 3 times 1 square times sine squared theta. So that's 3 times sine squared theta plus 3 times ab squared. So 3 times 1 times sine squared theta whole square. So that's going to give us positive sine theta raised to the power of 4. 3 sine theta raised to the power of 4. And finally, we're going to get negative sine theta squared whole raised to the power of 3. So that's simply sine theta whole raised to the power of 6. Fine. So let's now do the final simplification. So we have 9 plus 12 sine squared theta minus 12 sine theta whole raised to the power of 4 plus 4 times sine theta whole raised to the power of 6 plus 4 minus 12 sine squared theta plus 12 sine theta whole raised to the power of 4 minus 4 times sine theta whole raised to the power of 6. So we can see that 4 sine theta whole raised to the power of 6 cancels out. 12 sine theta raised to the power of 4, that's also cancels out. Negative 12 sine square theta cancels out. Positive 12 sine square theta goes away. So we're left with 9 plus 4, which is equals to 13. So this is the final value. Therefore, the value of the given expression, which is 3 times sine theta minus cosine theta raised to the power of 4 plus 6 sine theta plus cosine theta whole squared plus 4 times sine theta raised to the power of 6 plus cosine theta raised to the power of 6. So this particular expression, trigonometric expression, has a value equals to 13.